Okay, covalent bonds. Today, that's the conversation. So, covalent bonds are going to share electrons, unlike ionic, which transferred. So, in a covalent bond, it's one single covalent bond is going to be made up of two electrons that are shared. So, one electron is going to be donated um, to the bond from each atom. Okay, we'll illustrate that here in a little bit. Covalent bonds are common with your nonmetals. Um, when they are covalently bonded, they're going to be called molecules. Okay. Properties. Properties of covalent bonds. So covalent bonds tend to be weaker than ionic bonds. Um, they tend to have a lower melting and boiling point, and they are solid or liquid or gas at room temperature. And again, unlike ionic bonds, they are non-conductors. Remember, an ionic bond does conduct electricity, but a covalent bond in any state will not conduct electricity. Okay, so then you get to the chemical formula. A chemical formula in a covalently bonded set here, we call that a molecular formula. And it's important to bring that up because there's things called empirical formulas that we're going to talk about later. But a molecular formula is the exact makeup of one molecule. It tells me exactly how many atoms of each element are present in said molecule. Okay. All right. So then the next thing that we need to talk about is writing or showing covalent bonds. Okay. So we're going to do kind of like a rough sketch. Then we'll show the dot, and then you would show the Lewis structure. Okay, so if I'm drawing hydrogen gas, okay, hydrogen has one valence electron. I would draw my dot diagram like this, and I'm going to circle in this rough sketch here what is shared. So that is my shared pair. That's my shared pair. And so when I write the dot, so this is my rough, when I write my dot, it's going to look like this. And again, this is my shared pair. When I write my Lewis dot, oops, or my Lewis structure, I'm going to write it like this. And so a single line represents a single bond. Okay, so let's do a couple more. All right, so if I were to draw oxygen gas, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and if I circled my shared pair, so since they have 6 valence electrons, they're going to need 2 to share like this in order to fulfill that octet rule. Don't forget about the octet rule. Okay, so with that, there's my rough sketch. My dot is going to look like that. And then my Lewis structure is going to look like this. Okay, and this tells me that there is a double bond, which is 2 shared pairs of 4 electrons. Yes, yes. Okay, let's do nitrogen. Nitrogen has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so nitrogen has 5 valence electrons. So if I'm going to do my rough sketch, I know that I'm probably going to need to be sharing 3 pairs, right? So I'm going to share a pair. I'm going to share a pair, and I'm going to share a pair. So now I've got 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6, 7, 8 electrons. So that is going to be 3 shared pairs of 6 electrons. So to write that, it's going to look like this. 1, 2, 3, 4, 5, 6. It's kind of wonky. And then to write my Lewis dot, or my Lewis structure, it's going to look like this. This is a triple bond. Okay. All right, so a couple tips here. Always put the atom in the middle that must make the most bonds. So something that would need 2 more valence electrons, you would put the water or the oxygen there in the middle. So if we were to try to do water, which is H2O, I've got oxygen with 1, 2, 3, 4, 5, 6. I've got a hydrogen, and I know that my hydrogen is going to share, my oxygen is going to share. And so if I go through and count, I've got 1, 2, 3, 4, 5, 6, 7, 8. And that makes oxygen stable. There's going to be my dot structure, and then my Lewis is going to look like this.